Assalamualaikum. We are from Group 2. I'm Nur Aisyah binti Syahiruddin. My team members are Anis Syahira Izani, Muhammad Faizal Jamaluddin, Syazatul Izwana Syahari, Anis Syahira Nur Effendi. Our project title is Proposed Construction of Chicha Water Treatment Plant Phase, Jajahan, Kota Bharu, Kelantan. This presentation is about the environmental impact assessment for the proposed construction of the Chicha water treatment plant in Jajahan, Kota Bharu, Kelantan. The study covers multiple environmental parameters, baseline data collected through on-site monitoring and supported by secondary sources, the impacts during construction phase, mitigation measures, and also regulatory compliance. The study parameters for baseline study, impact assessment, mitigation measures that we have identified are ambient noise and vibration, ambient air quality, soil and land use, water and groundwater quality.
Hello, in this slide, I will present the environment aspect in terms of ambient noise and vibrations. The baseline study, the ambient noise monitorings were assessed at selected sensitive receptor, notably including Sekolah Kebangsaan Pasir Ho and nearby residential area. Said locations deemed as sensitive receptor due to their proximity to the project site and potential vulnerability to noise. The source of noise that we identified in this baseline study include local traffic, residential activities, and existing operations at adjacent infrastructure. The existing conditions, when we have noticed or identified the noise level in these areas, are currently within acceptable thresholds for suburban zones as per the guidelines for environmental noise limits and control 2019. Next slide is the impact of these ambient noise and vibrations. Use of heavy machinery such as pile drivers, excavators will cause elevated noise levels. Piling and drilling for tube wells are expected to produce significant temporary noise. The predicted noise levels that will be generated from these activities, such as hammer pile, will up to 125 dBA at source, estimated at 63 dBA at 500 meters. While for the concrete mixer, it will be 109 dBA at 1 meter, and estimated of 47 dBA at 500 meters. Noise is projected to exceed DOE suburban limit, which is 60 decibel per day, 55 decibel per night, near sensitive receptor if unmanaged. Lastly, the mitigation measures based from the impact that we have identified. Amongst it, we need to limit construction hours to daytime, which is 7 o'clock in the morning to 7 p.m. in the evening to avoid noise disturbance at night. Install noise barriers or hoardings, the temporary walls around the site perimeter. The usage of well-maintained and muffled machinery to reduce the emissions of noise. And lastly, the piling works need to be scheduled during school holidays or non-operational hours at nearby SK Pasir Ho. So that's all for me. Thank you.
Assessing the baseline ambient air quality is a critical first step in understanding the potential environmental impacts of construction projects. Baseline air quality monitoring was conducted over a 2-day period, focusing on key pollutants including particulate matter, PM10 and PM2.5, sulfur dioxide, nitrogen dioxide, ozone, and carbon monoxide. The results indicate that all measured concentrations are well below the Malaysia Ambient Air Quality Standard 2020 limits, demonstrating that the air quality at the project sites is generally good and not significantly influenced by industrial emissions. The primary sources of air pollution are limited to local vehicular traffic and dust from unpaved roads, which is typical for suburban environments. Given the proximity of sensitive receptors such as school and residential communities, this baseline characterization is essential to understand existing conditions and provide critical reference point for assessing potential impacts during construction. And we move on to impacts. Construction activities such as earthworks and the use of diesel power machinery are expected to increase emissions of particulate matter, both PM10 and PM2.5, as well as gaseous pollutants like nitrogen dioxide, sulfur dioxide, and carbon monoxide. This increase is particularly noticeable during the dry season, when soil disturbance and vehicle movement on unpaved roads generate more dust. These elevated pollutant levels can pose health risks, especially to sensitive groups, including children, the elderly, and workers over 50 years old. Short-term effects may include eye irritation, respiratory symptoms, and reduced visibility due to dust haze. Understanding these risks will help us prioritize effective mitigation measures to protect community health throughout the construction phase. In order to minimize the adverse effects of construction on ambient air quality, several mitigation measures are recommended. Dust control strategies include the regular application of water sprays, proper storage and covering of raw materials, and restricting vehicle space on unpaved roads. The second one is emission reduction, where emissions from machinery should be managed through regular maintenance and adherence to local clean air regulations. And then monitoring. Continuous air quality monitoring is also essential for promptly detecting any excess and enabling adaptive management. Finally, adopting sustainable construction techniques such as off-site prefabrication and leveraging digital technologies for real-time environmental monitoring can further reduce air quality impacts and enhance worker safety.
On this project, we also monitor the soil and land use. So let's take a look on the baseline study first. Usually for this project, we monitor the soil moisture, the characteristic of soil based on the borehole data, the soil loss due to soil erosion process, and sediment yield. Usually the causes of soil loss are due to dredging of aquifer, earthwork, and the surface runoff. So let's take a look on the existing condition for this project, where the unconfined and confined aquifer system for this basin and the proposed site at Pasir Hall consists of alternating layer of sandy silt, fine to coarse sand with trace of gravel and pebbles with variable thickness overlaid and underlain by layers of silty clay. And so you can take a look on the attached picture there. That is the example of the soil, this existing condition of the soil before the project commencement. And then three aquifer layers can be identified with lenses of less permeable clay and silty clay. Lastly, the aquifer system is underlain by granitic bedrock at depth of 180 meter from the surface. The hydrological system thickness can reach up to 100-meter thickness. Here in this part, we are going to discuss how this project will impacting the soil and land use at the project site. So the project site sits on the flatland. So meaning there is no significant soil erosion is anticipated due to cut or fill operations. But soil erosion may occur as a result of earthwork activities such as removal of unsuitable soil, construction of building foundations, and digging underground lines, pumps, wells, etc. Results in the generation of waste soil piles, tips in the project site. So any soils and waste soil piles that are exposed to the weather element may result in excessive erosion and sedimentation in the nearest receiving water bodies in the area if it is not properly controlled. Potential for soil erosion and subsequent sediment discharge may be significant if there is no proper mitigation during the construction phase. There are several activities that can be taken into consideration to avoid the risk of soil loss and sedimentation yield. So first of all, we can minimize soil erosion. A stream buffer shall be retained and natural waterway reserve should be delineated as recommended by the Department of Irrigation and Drainage Malaysia. Next, we can preserving topsoil and other asset where all excavated topsoil shall be stockpiled, protect from erosion and later used for revegetation. Next, what we can do is install a wash-through at the entrance of the project site in order to prevent dust pollution as part of the access routes and sites management. Next, we can do a runoff control and management, where this runoff diversion channels such as perimeter drain and internal earth drain shall be constructed. And then what we can do also sediment prevention control by installing silt trap to detain runoff from disturbed areas for a long enough period of time to allow for a majority of the core suspended soil particles in the runoff to settle out. And lastly, what we can do is site maintenance, where we do a regular inspection to plan before and after each storm event.
Hi and Assalamualaikum. My name is Izwana binti Syari. I'll continue to brief on the water quality and groundwater. So here the baseline study. So the identified nearby river at risk is Sungai Pangkalan Dato and Sungai Kubung Mulong, vulnerable to sedimentation from stormwater, especially during rainy seasons. So the construction impact is the runoff, chemical and waste that may degrade water's physical and chemical quality, especially during earthwork and site clearing. So the groundwater zone to identify is Pasir Hall lies in the lower Kelantan River basins, LKRB, a high potential aquifer zone with sandy permeable layer. So the monitoring finding is the water table is at 5.25 to 6 meter below surface, which has stable discharge, minimal ground movement. Aquifer remains sustainable under project use. Next, we continue to the impact and mitigation measure of the water quality and groundwater. So the first impact we found is sediment runoff erosion. The soil erosion due to land clearing and earthworks, the sediments that entering a nearby river. So the mitigation measure is we can install the silt fences, sediment basins and check dams, schedule earthworks during dry weather, stabilize exposed soil with mulch or vegetation, construct perimeter drains to manage runoff. Secondly, contamination from chemical and fuel. So the oil, fuel or hazardous materials spills reaching the drains and nearby river. So, the mitigation measure is we can store the chemical or fuel in abundant area with impermeable floor, maintain machinery to prevent leaks, do a monthly or weekly maintenance, provide spill kits and staff training towards the spillage mitigation, conduct refueling away from water bodies. Thirdly is the wastewater from workers' camp. So the discharge of sewage and grey water into natural waterway, it increase the BOD and pathogen. So the mitigation measure is we can use the portable toilet or septic tanks, treat grey water in stocks away pits, ensure regular dislodging and waste collection, prohibit direct discharge into drains or river. Okay, so for the groundwater, the impact we found is drilling and well flushing, discharge of muddy or silty water into the ground, risk of shallow aquifer contamination. The mitigation that we can use the line sedimentation pond to contain wastewater, avoid direct discharge on open ground, use non-toxic biodegradable drilling fluids. So, secondly is the groundwater level fluctuation, the temporary drop in water table from test pumping, and also the disruption to nearby private wells. Okay, so the mitigation measure is we can notify the nearby resident before pumping, conduct test pumping in phases, phase by phase, monitor groundwater level continuously, provide temporary water supply if needed. Okay, lastly, the impact we found is the risk of aquifer pollution, which is the contaminants entering aquifer from surface, poor well sealing or casing. So the mitigation is proper seal wells with bentonite or cement grout, use corrosion-resistant casing materials, locate wells away from fuel or chemical storage, test and inspect well integrity post-constructions. That's all from me. Thank you.
In conclusion, the EIA finding for the Chicha water treatment plant project demonstrate that while the proposed development offer significant socio-economic benefit through improved water infrastructure, it also possesses notable environmental risks, particularly during the construction phase. Key concern include sedimentation of nearby river, dust, and emission affecting air quality, noise disruption to sensitive receptors, and potential degradation of groundwater resources. These impacts are manageable through comprehensive and proactive mitigation measures, strategies such as land disturbing pollution prevention and mitigation measure, controlled runoff system, smart monitoring technology, and proper construction site management can significantly reduce environmental degradation. Moreover, adherence to national environmental guidelines and engagement with local community will enhance transparency, compliance, and social acceptance. Thank you.